Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Triangular Growth by B Alpha. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Every line has a beginning and an end. The direction is to be determined by the solver. Starting from the beginning, split a line into segments. The first cell is the first segment. The next two cells are the second segment. The next three cells are the third segment, and so on. All segments on the line have the same sum. And this sum may be different for different lines. Okay. The first cell is the first segment. The next two cells are the second segment. The next three cells are the third segment. And then we have 4 cells, which must be the fourth segment. And that's for any line. And all segments on a line have the same sum. And this sum may be different for different lines. So, for example, for this 6-cell line, it has to be going in one direction. We have one cell that must be a single segment. The next 2 cells are the second segment, and the next 3 cells are the third segment. And whichever way it goes, it could be 1 here, 2 here, and then 3 here. Or it's 1 here, 2 here, and then 3 here. We don't know which way. But say it went this way. Then we could have something like, say, 1, 2, and 5 here. And then we have 2 and 6 here, and then this would be 8. So the first digit here is a single segment. The next 2 cells are the second segment. The next 3 cells are the third segment. And 8 is the sum of the first segment, 8 is the sum of the second segment, and 8 would be the sum of the third segment here. So that's an example of how that works. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, we have a 10-line segment here. So that means we have a 10-cell line here, which means the segments must be 1 cell, 2 cells, 3 cells, and 4 cells. If we had 4 cells here, the problem is they would all have to be unique. Because we have 4 unique digits, they have to be unique because they're all in the same row. And you cannot have repeats in the same row. You have to have the digits 1 through 9 once each exactly. So this cannot be the end of this line, which means, so we're going to mark, we'll have, I don't know. So let's mark the single digit as blue, the next digit as green, the next 3 as yellow, and the last set of 4 as red. So this has to be 1 here, and these 4 must add up to what this digit is. Well, these again cannot be unique digits from 1 through 4. These have to be 3 digits adding up to what this digit is, and 3 unique digits adding up to a singular digit means a singular digit is 6 through 9. But if this were 6, this would have to be 1, 2, 3, and then this would be 4, 5 at minimum, so that doesn't work. What happens if this is 7? If this is 7, this is 1, 2, 4, adding up to 7. And this would then have to be at minimum 3 and 5, but that's too much. That adds up to 8. So this can't be 7. So this is 8 or 9. What happens if this is 8? If we have 8 here, this would either be 125. Well, these digits, okay. These digits add up to 1, 2, or 3. At minimum. So that means this adds up to 6 at least. 6 plus, you could have 2 or 3 here, or 1, to add up to 8 or 9. But if it's 8, then this would mean this is 1 or 2. These 3 digits would have to add up to 8. So it cannot be 125. That would eliminate all possibilities for that cell. So it would have to be 134. But then that would force this to be 2, and this would be a minimum of 5 or 6 here, which is not allowed to add up to 8. So therefore, this must be 9 here. That means this could be 1, 2, or 3. This could be 1 through 5, and we have a guaranteed that 1 is here. Because 1, 2, and 5 is the maximum you could have, or 1, 3, and 4 is the maximum you could have. Either way, you're guaranteed a 1 here. Anytime you have 3 unique digits adding up to a singular digit, you have to have at least 2 of them must be from 1, 2, or 3, right? So 1, 2, 3 obviously adds up to 6. That's 3 cells, 3 digits from 1, 2, or 3. 1, 2, 4 adds up to 7. That's 2 digits from 1, 2, or 3. 1, 2, 5 adds up to 8. 1, 3, 4 adds up to 8. Both of them require 2 digits from 1, 2, or 3. And to add up to 9, you have 1, 2, 6, 1, 3, 5, and 2, 3, 4, all of which require 2 digits from 1 through 3. So this is guaranteed to be 1 through 3 because to add up to 9, it's either 6, it has to be at minimum 6, plus 3, adding up to 9. So that's maximum of 3 here. This could be 7 or 8 also with the 2 or 1 here. And we have 2 digits here from 1 through 3, which means you cannot have 2 digits from the rest of 1 through 3, adding up to 9. So this has to be at minimum 4 and 5, which exactly adds up to 9. So this is 4, 5 as a pair. This cannot have 4 or 5, adding up to 9. So it cannot be 2, 3, 4 or 1, 3, 5. It's 1, 2, 6 here, adding up to 9. That eliminates 1, 2, 6 in the rest of the row. So no 1, 2 here. It's 3. So 3 plus 1, 2, and 3 add up to 9. And this can't be 3 because of 3 in the column. So this is a 1, 2 pair, which makes that 3 there. And so that's 9 digits there, adding up to 9. Sorry, 4 digits here, adding up to 9. 1, 2, and 3 plus 3 is 9. 1, 2, and 6 is 9. 4 and 5 is 9. And the remaining digits in this row is 7 or 8. For this line here, if this were the set of 3 digits adding up to a single digit, you would have to have 7, 1, and 2 at minimum. So this cannot be the end of the line. It has to be the beginning. So we have blue here, this is green, and then we have yellow here. So this is 7 or 8. That means we're guaranteed a 1 has to be here. We have to have 3 here because there's no other place for the 3 in column 9 because we have a 3 here and a 3 here, which eliminates 3 in the rest of the boxes there. So this has to be 1, 3, and it cannot be adding up to 7 because it would be 1, 3, and 3. So it must be 1, 3, and 4 here, adding up to 8 here. So this is 8, that's 7. To add up to 8, it's either 1, 7, 3, 5, or 2, 6, but 1 and 3, and 1 and 7 and 3 and 5 are eliminated because of 3 or 7 in the box. So this is 2, 6 as a pair. Okay. Remaining digits in this right central box, we have 1, 4, 5, and 9, but 1 cannot be here. So we're guaranteed 1 has to be one of these 2. Okay. Remaining digits of column 7. We have 4 through 9. No 4 here because of the 1, 3, 4 triplet in the box. These are 4 through 9 here, remaining in this upper right-hand box. No 8s here, no 4s here, no 6s here. This is 5, 7, 9 as a triplet, which eliminates 5, 7, 9 in the rest of the box. Can these two be the digits adding up to a singleton here? The answer is no, because it's 4 and 6 at minimum, which adds up to 10, which is not a single digit. So this must be the start here. So that's blue, and then this is green. So this must be less than this. So this cannot be 4, because that would force that to be 6. It cannot be 8, 4, and 4. Adding up to that. If this is 4 and 6, that's 2. If this is 6 and 8, that's 2, but this cannot be 4 and 8 there. So this is 2 no matter what, and then one of these is a 6, which eliminates 6 in the rest of the box. So 2 is here, that means this can't be 2 there. Can these two add up to that digit? And the answer is potentially yes. So you could have 4, 5 with 9 there. That is possible. Remaining digits of the central box, we have 3, 4, 5, 7, 8, and 9. Remaining digits of this left central box, we have 1, 2, 3, 6, 7, 8. Okay. One of these is going to have to be part of the set of 1 here, and one of them is segment of 1, and the other one has to be part of the segment of 3. Well, we're guaranteed 5 or 6 here. 5 plus 1 and 2 adds up to at least 8 or 9. If we try to have a 5 here, that would mean this is a 4-9 pair, and then this would have to be 8 with it. Okay, so either way, this is going to be the second cell. So this cannot be 9. 9 plus another digit is never going to add up to a single digit. So we have 4 and 5 here, which would make that a 9. Or this is 4 and 5 here, adding up to 9 here. Either way, you're going to have either 4, 5 here, and that's 9. And you're going to have 4, 5 here, and this is 9. And this digit sees all 3 of those digits, and they're all different. So therefore, this cannot be 4, 5, or 9. It's 1. Which means this is 1 there. These have to be the 2 adding up to the singleton that's here. So this cannot have a 9. Where is the 9 in this box then? In this right central box, it has to be here. So that's 9, which means that's a singleton, which means this cannot be 9 here. This is 2 digits adding up to that digit there. That eliminates 4 and 5 in the rest of the row. And 1 eliminates 1 in the rest of the row. This can't be 9 because of 9 in the row. So can this be 3 digits here, adding up to a singleton here? The answer is no, because 3, 4, that would be 3, 4, and 5 at minimum, which adds up to 12, which a single digit cannot be. So this must be the singleton here. This is the double, and this is the set of 3. Well, that means to add up to a singleton, it has to be 7 or 8. So then this is, to add up to 7, it's 3, 4. To add up to 8, it's 3, 5. So we have a 3, 4, 5 triplet in the central box, which eliminates 3, 4, 5 in the rest of the box. So we have 7, 8, and 9 here. Can 7, 8, and 9 ever be part of a triplet here, adding up to a singleton? The answer is no. So this is also singleton here. This is double. And this must be a set of 3 digits. 1 and 4 add up to 5. 1 and 5 add up to 6. So this is 5 or 6 here. 9 eliminates 9 as a possibility here. So this has to be 5 with 1 and 2 adding up to 8 here. So this is 5, 8 as a pair. That eliminates 5 and 8 in the rest of the column. So no 5, 8 here. It's 6 or 7. No 5 here. It's 4, which makes that 5. 4 eliminates 4 here, so it's 5. 1 and 5 add up to 6. This can't be 6 because of 6 in the box, so it's 7. 4 eliminates 4 here, so it's 6, which makes that 8, which leaves that as 4 there. So 2 and 6 add up to 8. 3, 1, 2, 3 add up to 9. 1, 2, 6 add up to 9. 4, 5 adds up to 9. Can these two digits ever add up to 7? The answer is no. We don't have 1 available. We don't have 4, 5 available. So that eliminates 1, 6, 2, 5, and 3, 4. So no 7 here. Can this be 8? Well, yes, if it's 2, 6, but that would eliminate all possibilities for that cell there. So this can't be 8, which means this is 9. So 9 is a sum of either 2 and 7 or 3 and 6. 9 eliminates 9 in the rest of the box. So we're guaranteed this is either 2, 7 or 3, 6, which means we have a 2 or 6 there. We have a 2 or 6 there guaranteed. That eliminates 2 and 6 in the rest of the row. Also, this digit plus 2 other digits must add up to 9, and they have to be unique. 7 is not going to work with 1 and 2. That's 10. So this has to be 3 here, which means this can't be 3. It's 2, 7 as a pair. 2, 7 eliminates 2 and 7 in the 2, 3, and 7 in the rest of the box. 3 and 6 plus 1 adds up to 10 at least, so this can't be 6. It's 1. So 3, 1, and 5 add up to 9 here. That eliminates 1 in the rest of the row. 5 is here. That means this can't be 5 here. This is 3, 4 as a pair, which adds up to 7. That means this can't be 7 there. It's 8. 6, 8 as a pair eliminates 6 here, so it's 2, which makes that 6. 5, 8. This adds up to 7, so it has to be 1, 2, and 4. So no 1 here because of 1 in the column. The 5 here with 1 and 2 add up to 8. That means we have to have 3 and 5 adding up to 8 also for the 2 digits. And the 2 digits are going to be either here or here. Remaining digits in column 8 are 2 and 9. So one of these is yellow, one of these is blue. And we have a guaranteed 1 and 2 have to be here. So 1, 2 with 5. So one of these sets has to contain 1 and 2. We have a 2 guaranteed here in rows 8 and 9 in one of these 2 cells. That means we have all the 2's accounted for in rows 8 and 9, which eliminates 2 in the rest of the rows. So this can't be 2, it's 4. This can't be 1 or 2. It's, sorry, 1 or 2 or 4. It's 1, which leaves that as a 2 there. So 1 eliminates 1 in the rest of the row here. And again, for the set of 3, you have to have 1 and 2 available. So this cannot be 1, 2, 5, which means this is a set of 3 here. So this is not yellow, it's blue. And these are the set of digits adding up to 8 for 2 digits. So this is 8, this is 5, this is 1, 2 as a pair. This can't be 2 because of 2 in the column, so it's 1 and 2 there. This is 3 and 5. This can't be 5 because of 5 in the column, so it's 3 and 5 there. 1 eliminates 1 here, so it's 6. No 2 or 6 here. It's 1, which makes that 2. 3 eliminates 3 here. It's 4. No 1 or 4 here. It's 3. 2 eliminates 2 here, so it's 9 and 2. This can't be 3 or 4. It's 1. We celebrate the 3 in the corner because we're getting close to solving this. 2 eliminates 2 here, so it's 7 and... Oops. This is 7, and that's 2. Okay. And we have a couple sets here that add up to... 1 adds up to 2. 2 digits add up to the singular digit. Okay. Let's do some normal Sudoku. Remaining digits of row 9. We have 6, 7, 8. Okay. Doesn't help us much. Row 8. We have 6, 7, and 9. No 7 here because of 7 in the column. 6, 7, 9. No 9 here because of 9 in the column. We have a 6-8 pair in column 3, which eliminates 6 and 8 in the rest of the column. So no, and this can't be 6, this can't be 7. It's 9, which leaves us as 6 or 7 there. Remaining digits in row 8. We have 3, 4. 3 cannot be any of these digits. So 3 has to be here. That leaves remaining digits as 4, 8, and 9. No 9 here, no 8 here because of 9 and 8 respectively in the columns. We have 3 here. Remaining digits of column 1 are 2, 6, 7, 8. This can't be 2, 6, or 8, so that leaves that as 7, which means this can't be 7 here. 7 eliminates 7 here, so this is 6, which means neither of these can be 6. We have a 2, 8 pair. That's not going to add up to a singular digit. So this must be the single digit here, and this must be a pair of digits adding up to it, which means this is 8, and this must be 2 and 6 adding up to that. 7 and 1 could add up to 8, but we already have an 8 in the box. 6 eliminates 6 here, so it's 8 and 6. 6 eliminates 6 here, so that's 8. No 6 or 8 here, it's 7. 7 and 8 eliminates 7 and 8 here, 6, which makes this 7. This cannot be 2 digits adding up to another digit because we can't have 2 and 7 adding up to 9 because of 2 in the row. No 1, 7 here adding up to 8. We have an 8 in the row, so this must be the singular digit, and it must have 2 digits adding up to it. And it cannot be 1, 6 or 2, 5 because of 2 or 6 in the row, so this is 3, 4 as a pair. 3 eliminates 3 here, so this is 4, which makes that 3. 4 eliminates 4 here, so it's 5 and 4. Remaining digit in column 2 is a 9. 2 eliminates 2 here, so it's 1 and 2. Remaining digits of column 3 are 1 and 5. This can't be 1 because of 1 in the row, so it's 5, which makes that 1. 7 eliminates 7 here. 9 eliminates 9 here. 5 eliminates 5 there. Okay. Remaining digits of column 6 are 4, 8, and 9. This cannot be 8 or 9 because of 8 or 9 in the row, so we have 4 here. No 4 here, no 4 here. Remaining digits of row 1. We have 1, 5, and 9. This can't be 1 because of 1 or 5 because of 1 or 5 in the column. So this is 9, which makes that 5, 7, and 9 there. 5 and 9 eliminate 5 and 9 here. So it's 1. 1 is not going to be the sum of 2 other digits. So this must be the end, which means this is what adds up to. Remaining digits of row... Well, 9 here eliminates 9 here, so that's 4, which makes this 8, which makes that 9. 4 eliminates 4 here, so it's 3 and 4. 9 eliminates 9 here, so it's 8. The remaining digits of row 2 are 5 and 6. This can't be 5 because of 5 in the column, so that's 6, which makes that 5. 1 and 6 add up to 7, which leaves this as a 3. And that's a solution. Pretty cool, actually. I did choose this because it was a different rule set, so it was very interesting. It's a very restrictive rule set, I will say, though, so it's not necessarily going to be something that you're going to run into very often. But you'll see variations on stuff like this. So that was very interesting. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.